Last question on the quadratic modeling worksheet. And so what we're going to do is we're going to look at this data and try to see if this data is going to fit quadratic model or linear model. Okay, and if it does follow either one of those, then we're going to try to come up with a formula. So I've got these 3 points, 11, 341, 18, 411, and 23, 471. So first I want to see, could these 3 points possibly be points on a linear function? So there are a couple different ways that you can do this, and we did this back when we were talking about linear functions. One way is to say, if I've got a linear function, it doesn't matter which 2 points I take, I should always get the same slope. So let's go ahead and try that. If I call these points point 1, point 2, and point 3, I'm going to try to find the slopes between them. So 1 and 2, I would say 411 minus 341 divided by 18 minus 11. This gives me 70 divided by 7, which is 10. Okay, if I take points 2 and 3, then I would get, let's see, 471 minus 411 divided by 23 minus 18, and that gives me 60 divided by 5, which is 12. And we see that these two are not the same, and since they're not the same, these 3 points are not linearly related. Okay, so we know it's not linear, so that answer is no. Okay, and now if it is linear, we want to find the particular equation. So that answer was no. If it is not linear, assume it is quadratic and find the particular equation. Now, let me just go over another way that you could have approached this question. If you wanted to know if it was linear, you also could have taken these 2 points, found the slope between those we just found was 10, and constructed a linear function. So using point slope, we might have gotten y minus 341 equals 10 times x minus 11. And then you would say to yourself, I know that both of these 2 points are on this linear function. They're solutions to this linear function. Is this one also a solution? If it is, we've got 3 points that all lie on a line, on the same line. And if it doesn't, then these 3 points cannot be on a function that is linear. Okay, so we might try 471 minus 341, and we want to know, does this equal 10 times 23 minus 11? So over here on the left, we would have gotten 130, and we're trying to say, does this equal 10 times 12? Well, 130 does not equal 120, so we would say, no, this is not linear. Okay, so those are a couple different approaches. Okay, so now that we know that they're not linear, we want to then say we've got these 3 points, we want to go ahead and find the quadratic function that they all lie on. Now, in general, if I have any 3 points, I can find a quadratic function that all 3 points are on. And that's a little bit of a fudge. Let me tell you when that doesn't happen. It doesn't happen when 2 of those points have the same x value, because there's no way to have a function that has 2 points with the same input and a different output. This is like an example that we had on homework a week or two ago. This also won't happen when the 3 points actually lie in a line. What will happen is when you're solving for your A, B, and C, you'll end up with A equals 0. So those are the only 2 times that you won't have 3 points that lie on a quadratic function. Otherwise, you can take any 3 points and fit them to a quadratic function. Okay, so let's go ahead and do this, and I'm going to switch over to a whiteboard in order to do this. So we've got the points. Whoops, I think I need to look back and see what they were again. Let me remember what they were. 11,341 and 18,411 and 23,471. All right, so here are my 3 points, and I want them to fit to a quadratic function. And so I input all the x values into my quadratic and also the y values. So here are my 3 equations. Okay, so I have 3 variables and 3 equations. So what I want to do is combine 2 pairs of them so that my c value is eliminated. So I'm going to combine the first equation and the second equation, and I'm going to take equation 2 minus equation 1 so that c cancels. I'm then also going to take equation 3 and equation 2, subtract equation 2 from equation 3 in order to cancel my c value. Okay, and this is what I get. So I get 203a plus 7b equals 70, and 205a plus 5b equals 60. Okay, so now my goal is going to be to try to eliminate a or b. So those are kind of big numbers, and I could say multiply the top equation by 5 and the bottom equation by -7 and then add them to eliminate b. And that would be totally fine. What I'm going to do instead is you might notice that the second equation, each one of those values is divisible by 5. And in the top equation, each one of those values is divisible by 7. So I'm going to go ahead and divide the top equation by 7, each term by 7, and I get 29a plus b equals 10. And the bottom equation, I'm going to divide each term by 5, so I get 41a plus b equals 12. Okay, and after I do that, I'm going to do equation 2 minus equation 1, because then that's going to eliminate my b. So if I do equation 2 minus equation 1, I end up with 12a equals 2, which tells me that a is equal to 1/6. Okay, so now that I have a equals 1/6, I can substitute a equals 1/6 into another equation that involves just a and b in order to figure out what b is. So I'm going to go ahead and use this top equation to fill in a equals 1/6. So now what I do is I get 29 times 1/6 plus b equals 10. So then b is going to equal 10 minus 29/6. Okay, and that gives me 31/6. Okay, and now I have a is 1/6, b is 31/6, and now I need to figure out what c is. Okay, so I can use any equation that involves a, b, and c. I might take this top equation, and I'm going to go ahead and write it on the next sheet. Okay, so I was taking that equation involving a, b, and c. Here are a and b, and I'm going to fill them in. 121 times 1/6 plus 11 times 31/6 plus c equals 341. So I went ahead and multiplied these, like 121 over 1/6 is 121 over 6. Remember, when I'm multiplying, this is like 121 over 1, and we multiply straight across. Or 11 over 1 times 31/6 gives me 341 over 6. Okay? And then so adding those two fractions together that have a common denominator, I get 462 over 6 plus c equals 341. 462 divided by 6 is 77. So we have 77 plus c equals 341, which tells us that c equals 264. So now we have a, b, and c. And so y equals 1/6 x squared plus 31/6x plus 264. And that's actually our quadratic function that all three of those points are on. Ask yourself if you remember how to check this answer. Okay, and then make sure that you can check it. I'll give you one example. We know that the point 11, 341 needs to be a point on this quadratic function. So you need to ask yourself, is 341 equal to 1/6 times 11 squared plus 31/6 times 11 plus 264? Okay, so check that for yourself. Make sure it's true. You should also check this for the other 2 points. That point 18,411 and also 23,471. It is a requirement that all 3 are on that quadratic function, not just one of them. Okay, I hope this helped. Let me know if you have questions.